This video is probably going to be the longest one of the unit, and I do apologize for that. There's just a lot we need to cover when you're first learning how to do stoichiometry. So the next ones will be much shorter, and the one for the next class is very short. So let's jump right into it. What you should have in front of you are your notes, your periodic table, and your stoichiometry quick guide. I'm going to be flipping back and forth between those as we go through this and do the problems. First thing in your notes, you will see this obnoxious disclaimer about units, okay? Units are everything in stoichiometry. What we are doing is converting from one unit to the other. Chemistry units have two parts, the measurement and the substance. So you should always have both parts of your units. Now in unit 3, what we're doing now with composition stoich, it is not going to be very imperative that you have both of your units. You will not get confused if you forget. However, I do require that you do it because when we get to unit 4, if you're in the habit of always having your substance, it makes it a lot easier when we get to those more difficult problems. Okay, so always write both parts of your units, no exceptions. Here are the steps for stoichiometry. This is in your quick guide, but I also put it in your notes because I wanted you to have it in your notes as well. So we're going to go through these steps as we do some example problems. So we're going to start with just 2 conversion factors. You will see on your quick guide we have a total of 7. We're going to learn 6 over the course of Unit 3, and then that 7th one won't come into play until Unit 4. So we're going to start with 2 conversion factors, and those 2 conversion factors are going to be this and then the reciprocal of that. Now, quite honestly, particles can be anything here. Like honestly, anything. But what you're most going to see in our class are atoms, molecules, and formula units, which is just the ionic version of a molecule. Molecules are covalent. Okay, so anytime you see any of those 3 things, you can use these 2 conversion factors. So we're going to do this first example, and I'm going to go pretty slowly through this first example and make sure you know how to use all of the stuff on the quick guide. So the first step on your quick guide says start with what you are given, write both parts of your units, and put your given over 1. This should start to look pretty familiar because we did this for our metric conversions when we learned dimensional analysis. So I'm going to start by underlining my given because I know that's what I do in problems, and circling what I'm looking for. And then I will take my given with both parts of my units, and MOL is the abbreviation for moles, and put it over 1. So before, when we did dimensional analysis, we looked to the prefixes to figure out how many factors we would have. Now we're going to use my handy unicorn diagram. So let's talk about the unicorn diagram. The unicorn diagram is actually pretty helpful. It will help you learn how to do stoichiometry. For now, in Unit 3, we're just going to use this side of it. Okay, we're not going to go over the rainbow to the other side because this side is for composition stoichiometry, and then we use both for reaction stoichiometry. You can ignore the A's and B's for right now. We'll use those in Unit 4. So for right now, you just look here. Okay, so let's talk about how this works. Every unit gets a factor. So in our problem, that we are at right now, we are going from moles to molecules, which you know is a particle. So from moles to molecules. Moles is right here. Particles is right here. Do you see how they are connected by a line? That means we can go directly from moles to particles. So moles is going to be one factor, and particles is going to be another. And that means we only need two factors, moles to particles. We'll talk in a minute about what we do when we need more than two. But because these two are connected by this line, moles to particles can be a two-factor problem. So I'm just going to write my two factors. So that takes care of step number 2. Step number 3 says drop down both parts of your units. If you remember in conversions, we did this all the time when we were learning dimensional analysis. And I said it would become helpful in the future. You take what unit is here and you move it down to the next factor, just like we did in dimensional analysis. This is dimensional analysis. Okay. And then step number 4 and 5, we can kind of skip. For this, we'll get to that in just a minute, okay? So what you'll do is the top of your last factor, just like in conversions, is always what you're looking for. So I might write myself a little note on my notes paper, top of last factor, always what you're looking for. So then that brings us to number 6. You can skip over 4 and 5 for the two-factor problems. Number 6, plug in numbers based on your conversion factors. Your conversion factors are on the back of your quick guide. Okay, the only two that we have are the first two. We're going to learn the rest of them later. So the first two right here. So you need to match up the units in your problem with the units on one of these factors. Okay, so let's take a look at our problem. We have the units right here. Molecules or particles is on the top. Moles is on the bottom. So now I go to my quick guide and I find the one that has particles on the top and moles on the bottom. And then all you have to do once you find your conversion factor is just copy these numbers. So we're going to copy 6.02 times 10 to the 23rd on the top and 1 on the bottom. And then all you have to do is multiply across the top, multiply across the bottom, and divide. So we will get this. Moles cancels, and we're left with just molecules of BF3. So let's try another one of these. Here we're given atoms, which is a particle of Na, and we're looking for moles of Na. So we're going to do the same set of steps. We're going to start with our given over 1. Oops, atoms. And then we go to the unicorn diagram to figure out how many steps we need or how many factors we need. We are at particles, and we want to go to moles Since they are connected, we just need two factors. Next step, we drop down both parts of our units. So atoms of Na goes here. And you know that what we're looking for goes on the top of the last factor. Since this is only two factors, we can just throw it up there right now. Now we need to match up our units with one of our conversion factors. And this is where students get a little thrown off, because they just go up to this example and they copy the numbers 6.02 times 10 to the 23rd on the top and 1 on the bottom. But what you need to do, there's no shortcut here. You need to take your units, moles on top, particles on the bottom, and you need to go to your quick guide and match that up with one of your factors. So we have moles on top, particles on the bottom, so we need to pick this factor. It's the same numbers, but it's in a different orientation. So instead of having 6.02 times 10 to the 23rd on the top, we're going to put it on the bottom. And again, the reason this is different is because the units are different. It all comes from whatever your given units are. So here, our given had moles, and here our given has particles. So as soon as we put that here, then we drop that down, and everything else is dictated by those units. So then we can go ahead and solve this. And in class, we're going to go over how to plug scientific notation into your calculator a little bit better. So if you try to do this right now, you're following along, you try it, and you get a different exponent, don't worry. We're going to cover that in class. Just follow along with what I'm doing right now. All right. So we can also use molar mass, grams per mole, which is what we did last class, as a conversion factor. So those conversion factors are going to be x grams over 1 mole and the reciprocal of that. X, in this case, is the molar mass. That's why we spent all last class going over that. So now you know how to do it. You can do it real quick and just plug it into your expression. Okay, so X is going to be the molar mass, and it's going to be determined by whatever substance is in the problem. So let's do this. We are given is 3 moles of H2SO4, and we're looking for mass. Mass is in grams. So anytime you see mass, it's going to be grams. We take our given, put it over 1, and then we go to our unicorn diagram to see how many factors we need. Here we are going from moles to grams. They are connected by this line, so we can just have 2 factors. Then we drop down both parts of our units. And what we're looking for, you can put mass. I usually put grams because that's what it is on the chart. Then you're going to match up these units with one of your conversion factors. And now on our unicorn chart, in our quick guide, we have 4. So what you need to look for is the one that has grams on top and moles on the bottom. So that's this one right here. You can go ahead and put a 1 in right away. And then you're going to want to calculate what the molar mass of H2SO4 is. So you can throw that 1 in there. And then when you do out the molar mass of H2SO4, you get 98. So that comes out to be 294 grams of H2SO4. Okay, I want to do one more example for you so you can see what happens if it's not two factors, what that looks like. So here we have 104.5 grams of HCl, and we're going to be looking for molecules of HCl. So we start out the same way. But you're given both units over 1. When we go to our unicorn diagram, we're starting at grams still, but we're going to particles. There is nothing connecting grams to particles, and that's because you cannot go from one to the other. We don't have a way to do that. Moles is really like the glue that holds all of stoichiometry together. You often have to go into moles in some way or another. So here, if we're going from grams, the only place we can go is moles. That's the only thing grams is connected to. And then we can go to particles. So grams gets one factor, moles is going to get another factor, and then particles is going to get a third factor. So that's 3 factors instead of just 2. And again, that's because grams and particles are not connected. So it's kind of like when you can't find a direct flight. Okay, you don't really want to go to Denver. You're trying to go to LA, but there's no direct flights to LA during the time that you want to go. So you're here in Boston. Instead of going directly to LA, you have to go to Denver first. There's no direct flights. So that means you're going to have a layover. So it's kind of like moles is kind of like the layover here. So we know we need 3 factors. And then we know we're going to drop down both parts of our units. You also know that whatever you're looking for goes on the top of the last factor. So you can go ahead and put molecules right here. This tells you what goes on the top of the second factor and therefore what you end up bringing down. So if you look at rule number 4 and 5, we skipped over them last time. Look to the unicorn diagram to determine the unit on the top of the factor. And then 5 says repeat these steps until all of your factors have units. That's going to be more helpful in unit 4. So you look to the unicorn diagram to determine the unit. So not only does this tell you the steps, it also tells you what goes on the top of each factor. So we have grams on the top of our first factor, and then moles goes on the top of our next factor. So this is like a roadmap. Okay, so grams, then we go to moles. So we're going to put moles on the top here. And then you always drop down your unit. So as soon as we have moles up there, we put it on the bottom here. And that, quite frankly, is the hardest part of stoichiometry, is just figuring out the units. Once you have that, it's pretty easy to figure out the numbers. So all we have to do once we have the unit is match up each factor with a conversion factor. So here we have moles on top and grams on the bottom. That's this one right here, moles on top, grams on the bottom. So we'll put a 1 with moles and then find the molar mass for grams. Molecules on top and moles on the bottom. That's this one right here because we know molecules is a particle. So molecules on top, moles on the bottom is right here. We can just copy those numbers. And then when you do out that math, So in class tomorrow, we will do bunches of practice on this, okay? So just come in with your notes filled out with some idea of what we're doing, and we're going to go over it together as a class.